Why don't we go ahead and get started? Welcome everyone to our Q3 chapter event. Wanted to give a quick shout out and thank you to our event sponsor, Stream Data Centers. I also wanted to quickly remind everyone of 7x24's mission and why we're here. And this is international and the local chapters. So I'm just reading it verbatim. So bear with me. 7x24 Exchange is the leading knowledge exchange for those who design, build, operate, and maintain mission-critical enterprise information infrastructures. Boy, that's a tongue twister, mouthful. Our goal is to improve end-to-end reliability by promoting dialogue, continued learning, and industry engagement. That being said, it's awesome to see so many familiar faces on the call, and also exciting to see some new ones. Lots happened around the world since we last met. Probably don't need to say this or remind everybody, but COVID-19 has consumed our thoughts, families, and lives and impacted each of us in different ways. In addition, we've seen significant civil unrest across our country. We've all had to adjust the way we work and support our families. On a personal note, I mean, and I know probably each of you have your own stories to share, but my wife and I are both used to working from home. But then you add the dynamic of a 4-year-old at home full-time that demands your constant attention. Let's just say it's been challenging but fun. I also wanted to note that international, I saw the notes on international site. After 30 years of uninterrupted conferences, they made the decision to cancel the 2020 spring conference as expected in Orlando. I believe they're still planning on having the fall conference here in Phoenix at the JW Marriott, October 25th through the 28th. More to come on that, and we will keep you informed as they make progress towards those dates. We have a great agenda today. Mark Bauer, your chapter vice president, is on the call and will provide us with a market overview. And then returning as our guest speaker, Dean Nelson, founder and chairman of Infrastructure Masons and interim CEO at Virtual Power Systems, will talk about micro edge, digital labor, and software-defined power. I'll turn it over to Mark.
Thanks, Rich. It's nice to see everyone again. I'd like the opportunity to introduce Anthony Bollner with Stream Data Centers. They have graciously sponsored this luncheon event. Hopefully everybody had an opportunity to be able to take advantage of the Grubhub luncheon. A little bit different than what we're used to, but pretty exciting. So I'd like to introduce Anthony. Anthony, thank you for your support here. Thank you for your team's investment into Arizona and Goodyear specifically. And look forward to hearing a little bit about your company and actually your development since you've been under construction and going to be delivering some product here in the next month.
Well, thank you, Mark. Just to test the audio, make sure folks can hear me, and got a thumbs up there from Dean. Thank you. Good to see some familiar faces. Dean, good to see you. Mark Bauer, obviously been a friend for a long time. I think Bauer and I have probably known each other most of 20 years. So, and Michelle, thank you for your help in pulling this all together. So very quick, high-level introduction on Stream Data Centers. We are based in Dallas, and Stream has been a active investor, developer, and operator of data centers for over 20 years now. Actually started in 1999. So probably several familiar faces on this call and certainly in the industry. We are excited to be entering the Phoenix market. We acquired a very large building and a very large piece of land in Goodyear just over a year ago now, and have been active in the design and development and the build out of that building. So we are building out a 418,000 square foot building in Goodyear on South Litchfield, which is just south of the Goodyear Airport. If anyone is familiar specifically with that area, we are very excited about being in Goodyear for some specific reasons. We've had
Looks like we lost Anthony.
Don't you just love technology?
And we are building out 4.5 megawatts of capacity at the building, which we'll deliver in very early September. So we will have fully commissioned capacity in September, and the brand new substation will deliver in that same time frame. And we, in addition to that, I just want to stress the flexibility. We have 157 acres of land in this very large building. The building itself scales to about 40 megawatts, and the entire campus will scale to over 200 megawatts. So that really gives us the ability to develop buildings for end users. It gives us the ability to scale large users and also work with, smaller enterprise users. So we just have a lot of flexibility to serve the data center needs of the Phoenix market. I could go on about connectivity or incentives and other things, but I'd really probably like to just leave it there. And if there's any questions, any discussion of data center market in general, I'd probably just add to it, Mark, as you take it.
Thank you, Anthony. I think one question, the connectivity piece, for 5 years ago, that was the limiting factor out on the west side.
Sure.
It doesn't seem to be the case today. Obviously, we've had some of our hyperscalers kind of help, deliver more of that connectivity. If you wouldn't mind just touching upon that, because, that is a very important. You can do everything you can to build a data center, but without that connectivity piece, it really challenges. And I think that Goodyear in that area has stepped up to assist.
No, you're exactly right. And I'd say 5 years ago, the fiber provider out in that area was Cox, and still is. And Cox continues to invest in their network there. In addition to Cox, though, Zayo and Crown Castle are spending significant dollars on their infrastructure out in that area, and in creating long haul routes to the West Coast, Southern California, Northern California, Utah, as well as the Pacific Northwest. In addition to that, the dark fiber loop, which we have created that takes us back to the carrier hotels, into the heart of the Phoenix market, is another very important part of the connectivity story.
Perfect. Great. Thank you. If anyone has any questions for Anthony, go ahead and shoot. Otherwise, thank you very much for that overview, that introduction of your company, and looking forward to working with you out here in Arizona.
Well, thank you, Mark.
Overall, the impact of COVID across the country has certainly had its impact on tours. I can say, tomorrow, I've got a tour of a data center facility, and the processes of a tour are a little bit different. There will be some, they'll take a temperature. Obviously, there's a limited amount of people that are able to go on that tour, and everyone has to wear a mask. That's across the board, across the country. And I'd say that, these physical tours are just beginning. Activity to acquire space up until the signing of a lease was virtual tours. I would also say that many of the data center operators that are doing tours have stepped up and put virtual tours together to really provide an overview and a walkthrough tour without doing the physical tours. I would say that, nationally, everything, 80% of the business being done right now is hyperscale cloud, social media, the Facebook, bike dance. I mean, that's probably where the majority of the activity has been over the last 90 days, and not surprising. Virginia, Chicago, Dallas, Phoenix, and certainly Northern California are certainly seeing absorption, but Not the absorption numbers that we saw in 2019. It has slowed, but the majority of, like I said, the majority of the space across the country is really being, led by the hyperscale and social media. Come down into Phoenix, I would say, 2019 was certainly the year of land acquisitions. So data center hyperscale developments were acquired, as well as companies such as Stream and Compass, Raging Wire, that acquired land last year, have been in the design modes of designing their sites and actually building. Compass has built out 2 buildings. They are powered shell. One is a 6 megawatt powered shell. The other is a 35 megawatt powered shell. Anthony just got finished telling us about their development out in Goodyear. Those processes did not slow down. For Raging Wire has, which is NTT now, they are building out their substation and moving forward out in East Mesa. Aligned continues to build out their capacity. They're on their 3rd phase of their development. And the only thing that's changed, I think, from a construction perspective is the way that their crews have to go on site. All of those, I would say, Aligned's crew is a very limited crew in terms of actual salespeople, and they only have the engineers that need to be there on site. You've obviously got your Google, who's planning their site in East Mesa. You've got, as we discussed, our big cloud provider out in Goodyear. Their 3 sites are up and operational now, and that took them 12 to 18 months from start to finish. We also had, in terms of activity, probably in March, we had a new entry come into town, which was Landmark Dividend. Landmark Dividend acquired a corporate-owned data center that was leased back 50% by that corporate client, and they are marketing the balance of that space. It was a project that has 3 different environments. So in terms of new names coming into the market, that is one of them, Landmark Dividend. I think as it relates to ground up developments, you've got Digital Realty, Cyrus One with land. They have not broken ground in East Mesa. Edge Connect still has their land. But I think that the whole overview thought of the market is that we're very strong, stable. Big commitments are still being evaluated by corporate clients, so it's taking a little bit longer. Existing tenants within the co-location facilities certainly are looking for future ability to expand. And the remote working has certainly put a lot of pressure upon these companies to test their abilities for technology. And that's one of the things we're seeing with, JLL is a big company. We provide all different types of services, office, retail, hospitality. And just from a company perspective, all of those clients are still unable to make long-term decisions. They're mostly short-term decisions, all pending on what their back to work environment might look like going in the next 3 months, 6 months, let alone long-term. So, assisting from a global perspective, those clients to make sure that they've got the IT available for their work at home employees has been top of mind. We have calls with our clients every day on those issues. I'd like to kind of just open that up. I mean, obviously, our absorption for 2020, we're at about 20 megawatts. Last year, for the entire year, we were at 25 megawatts. So the outlook is still very strong for data centers in Phoenix, development in Phoenix, and the total cost of occupancy continues to be one of the top 3 to 4 markets in the country. So I'd like to just go ahead and hand it back over to Richard to make a further introduction of Dean Nelson.
Thanks, Mark. Yeah, and I wanted to take just a moment and provide a deeper introduction to Dean. I've known Dean for, what, 11, 12 years now, Dean? I think we first met when you were still at Sun Microsystems. Dean hosted an offsite for us to discuss Tier 4 design principles and how to apply those to our newest data center in Salt Lake City, eBay days. Then just more on Dean. Dean spent, as I mentioned, 17 years at Sun in various technical and executive leadership roles before moving to eBay, where he was vice president of Global Foundation Services, driving tremendous innovation and influencing multiple layers of the technology stack. Dean also led the metal team at Uber, responsible for metal as a service, technical infrastructure, and business functions. Dean is founder and chairman of Infrastructure Masons and current interim CEO at Virtual Power Systems. Dean has been a huge influence over my career, my boss, a mentor, and longtime friend. Dean?
Well, thanks, Rich. That's that's really cool. I'll go into the presentation in a minute, but I just want to say I got a warm spot for Arizona. You know, pun intended, I guess. But the key is I've had the luxury of being able to build a lot there, have teams there. You know, Rich and team across there has just been amazing. And you know, I listened to all the different growth things that you just said, Mark. It's very cool. Yeah. It's very nice to see that there are a minimum of 3 hyperscalers in Arizona now. Right. And 2 of them going to very large scale. And I think that's just that's what's been needed. And so I think you know, you said you're one of the top 5 markets in the country or in the world.
That's correct. Yep.
Okay. So I've always said this, and I got in trouble in Northern Virginia saying Arizona's catching up. Watch out, Northern Virginia. Right. And but that's all right. The whole point is everything is growing. The entire industry is growing, and the U.S. is really the key where it starts. Europe starts to expand, but APAC is just going to explode, right? So anyways, I love hearing all those different things. Landmark coming in and, you know, stone throw away from Stream, another hyperscaler, right, Anthony? So I think it's there's just some very interesting things going on. But what I wanted to do today is just give you an overview. And I'm talking to you as Dean Nelson Inc., okay? Independent. I can talk about lots of different things. But I wanted to go through 3 primary things that I thought were interesting. Ones that are trends that people should, you know, just get your teeth into a little bit, because I think it can affect quite a few people in different ways, right? But being aware of it is the most important. So let me jump into this presentation. There we go. And of course, we've got to call this Geek Out. So we're going to geek out for a little bit. Okay, everybody can see that? All good? All right. Excellent. Well, I'm going to start with this. So this is me at 21. All right. When Rich was talking about Sun Microsystems, that's, yes, I have a mullet, and yes, I have that mustache. But back in the day, you know, I started on my 21st birthday at Sun Microsystems, and I was doing component level debug on hardware. That's a Sun 330 Stingray server. I still remember it, right? The layouts and the other stuff. And I love that. But if you fast forward, what's happened over the last 30 years, I had 17 years of Sun, which was great. And what I loved about Sun was the culture and the innovation and being able to just learn all these different things and jump into all these different roles. You know, it was just, I think I went to the University of Sun because I learned business and finance and leadership and just so many different things at that company. It was really a unique place. And as Rich was saying, I jumped back into eBay Inc. In 2009, and what a ride that was. That was very cool to, you know, have a turnaround come up. And then, you know, Rich can attest to this too. Being able to now take and integrate eBay and PayPal together for 15 months, then stand them up as completely separate companies in another 10 months, and the gavel fell on the stock exchange and everything worked. that was a very, very rewarding experience. I mean, the teams, the people, being able to work with people like Rich and Sean Tugwell and just the hundreds of other people across that company were awesome. And then I did take a 6-month sabbatical, which was very much needed after that 25 months of fun. And then I jumped into Uber, and that was another incredible ride, for another 3 years, just trying that same type of hyperscale, getting them back in, and how do you standardize and get things to grow? But also just such a disruptive thing when it comes to the way transportation is done and all the different verticals, and then how that translated back into infrastructure. And so I left in July last year, and that was on my 51st birthday, literally. So I did 30 years exactly of operational roles, engineering roles within our industry, and really enjoyed it. But I wanted to do something a little different. So what is that? Well, taking this $10 billion worth of infrastructure stuff I've been able to do, how do you apply that? And everybody asks about what's next, and I say exactly, that's I love to work on things that are next. What is the stuff that's going to start to change the way we're doing this? But what I wanted to do today is just give you a little bit of the, first, the global demand. Take a little bit what Mark was talking about, but look at it from a global perspective. And if you look at it right now, there's over 500 hyperscale data centers processing over 50 zettabytes of data. Okay? There's debate about this, but they're consuming 2.6% of the global energy annually. Okay? Lots of different opinions on that one. The bottom line is it is growing. And when you start to look at what the future is, there's a prediction right now of 175 zettabytes worth of data being generated every year. Okay, zettabytes of data every year. 50% of that's going to be at the edge. So in the next 5 years, we're going to do a 3.5x growth minimum of data. And I will tell you, today, I believe that number is going to be bigger, because the pandemic has changed all of this. It's accelerated 3-year digitization projects to 3 months. So, and if you heard one of the Infrastructure Masons interviews I did with Noelle Walsh, she had deployed 100 megawatts of new capacity in 2 weeks. 100 megawatts of new capacity globally in 2 weeks. Now that's across the board. That's new construction they were doing, to spinning up in different areas, to partnering with colo providers. But just imagine that. The whole point was the pandemic added so much demand that they had to expand that rapidly. That's one hyperscaler. Now just imagine what the future is when you start to look at this number. And if that number gets bigger, and we have the edge stuff that's going on, there's just a huge amount of demand, right? We call this the data tsunami. That wave is coming. And, I don't know if zettabyte is a big number, okay? And I didn't even know what's after this one. So when we're talking about yottabytes, I mean, it's just, we never even fathomed we would get to zettabytes, right, 10 years ago. And the amount of data is just staggering. So one of the things that we did, we held an end user summit with Infrastructure Masons last year, and we had 100 people, senior leaders across different companies, and in that we had them start to do some predictions. And the predictions that we're saying align to this one. Started looking at a 39x increase as a ceiling. 39x increase. I can't even put my arms around that, what that looks like. But that's the kind of things that are happening, because this curve has been so dramatic, especially over the last 10 years. It's just going to continue to go back up. So for us, why is that happening? If you look in the past, there were 13 billion people and connected things. This is the cloud era. This is where everything is growing. But what's coming up in the future is more than 100 billion things. And they're talking about trillions of things when you look at RFID technology and things that are now the size of a grain of sand. The amount of units that are going to be out at the edge and the amount of things that are going to be required is just going to keep driving that need. And a lot of contention around this number. Is a minimum, it's 1% of global consumption today. I still think that number's off by a factor of 3 at a minimum. So when you look at the 2.6, I think that's a pretty safe bet. But one of the things that we, as an industry, have had the luxury of is the advent of PUE Think about that. That was 2009. I remember putting out my first blog saying, I'll show you mine if you show me yours. That was at Sun. And we did this, right? Put these numbers out. And it was a really, really fun exercise. But if you look at what happened over that period of time, that 10 years, everyone said, oh, well, it's all up by 550% when it comes down to compute. But we're less than 6% when it comes to data center growth and power consumption. That's not an accurate picture. The picture is that we flattened that curve. We picked all the low-hanging fruit. The majority of data centers rolling out there are already optimized. And if you're not going to be able to compete. So the whole point is now we've picked that fruit. What does the future look like? Highly efficient data centers that start to now scale even faster. That's why the consumption will continue to go up. And so the big thing for me, and I'm a big advocate on this side from the iMason standpoint, is how are we going to support that unprecedented scale, that growth, right, sustainably? How are we going to go back and do our part when it comes to climate change? And what I am very proud of is the people that have come together. We just launched this new sustainability vision. And it's unifying all the different folks in here to say, can we make sure that every click improves the future? Can we, as an industry, really drive that? Because there's a lot loaded in those words. Because for us, we really have to have an infrastructure that it benefits the global economy and society without impacting the planet. Now, if you look at the people that are involved in this, we've got over 30 different companies and hyperscalers that have unified behind this vision. That's the kind of stuff that we can actually do to help reverse climate change. So I want to make sure that goes back out there because we all have a responsibility in what we're doing. And I know that everybody on this call takes this very seriously. When we go roll that out, we do the best thing for our business. We do the best thing for our customers. And we also need to make sure that we're doing the best thing for the planet itself. So I applaud, of course, in Arizona, there's a lot of renewable energy. And you look at it, low impact or low carbon concrete, low carbon steel, all the different decisions that are made in the supply chain of going to do this. And one of the topics I'll talk about today is another opportunity for us to do our part in there. Okay, so now let's go into trends. So I'm going to talk about three different things: digital labor, micro edge, and software-defined data center. So this is a summary. Digital labor right now, they believe, is going to disrupt 40% of the jobs that are out there, okay? In the end, we've got to create a hybrid world where digital employees and humans are actually working in concert. Second, micro edge. When you think about what we were talking about with the data growth and that data tsunami, we have been doing everything at the core and expecting latency out to the people that are performing it. It's all going to change. And that's going to keep driving more and more data closer and closer to the user. And what I believe is down to the last 1,000 feet. That's where the future is going to be. There's going to be multiple layers where data is generated and where we're going to have to actually process it, drop it, dedupe it, etc. And then we still get it going back to the core. Well, then that goes into the data center itself. If we get to this 10% of global energy consumed, there's a microscope on us. There already is right now. How do we ensure that everything we're doing is as optimized as possible? It's as sustainable as possible, and that's actually going to give every click improves the future the reality that it needs. So there's a way that we need to approach this that we haven't done in the past. Okay, so the first one, digital labor. Let me just give you a quick summary of it. Okay, humans and machines uniting. This sounds like, what's that called? The movie Terminator, right? Human and machines and taking over. But the reality here is there's going to be more and more opportunity because we have optimized digital labor. And 133 million new roles are going to emerge because of what's happening with this hybrid approach. Okay, and $2.9 trillion, yes with a T, $2.9 trillion of business value is going to be generated, right? Think about it, 6.2 billion hours of worker productivity is going to be generated through this too. Because humans can only scale so far. And let me give you a perfect example of this. In February, the majority of companies had no idea the wave that was about to hit them in customer support. The pandemic has now exposed the weakness the majority of companies have right now to scale. And that's a people challenge. And you can't just keep bringing more and more people into it because we have limitations now with social distancing, travel, etc. How do you scale a business? The only way to do that is to now augment with digital labor. And I don't know about you, but when flights canceled and hotel bookings and credit cards and whatever else, and you're on 6-hour wait times, basic things like that are because so many people are all calling in to do something. Digital labor is going to change that. So, 15 trillion or 15% of the actual customer service interactions will be handled by this. 52% of the tasks that are currently done today are going to be done by machines, compared to what's going on with 29% from 2018. And get this fact, 64% of people are going to trust an actual robot over us. I know it sounds scary, but in the end of it, it's consistent. It will always go back and follow a governance process and rules, etc., and you will get a common answer. So there's a very big difference here. Just a big picture about what's going on in digital labor, right? The future of work that's happening. And look at the market comparatively. So RPA is robotic process automation. So just think of standard automation within infrastructure itself. That's a $12 billion market, by next year. Then you look at artificial intelligence software. That's a $7 billion market going to $24 billion by next year. Cloud infrastructure, $272 billion going to $340 billion. Digital workers just dwarf it all. $2.9 trillion. $2.9 trillion. It's all about how we efficiently actually scale to demand for people globally. So I want to introduce you to someone. Her name is Amelia. All right? And Amelia is the world's first cognitive AI augmented digital labor human. Digest that for a second, okay? You're able to have a real world natural language conversation with her to do the things that you need to get done. Now, first off, who is Amelia? Amelia is basically a front end that allows you to have a human conversation with an AI, not a chatbot. Because in the past, when you go in and type something into a chatbot interface, you get back the answer that you weren't expecting, or some canned response or something. Imagine now the cognitive capability of it. Amelia can break apart what you're looking for, find intent, be able to do context switching between your conversations like you would have with the human. It'll also learn what's going on with you. And it has that interaction in real time that allows you to say, I want to log in and say, I want to take a vacation on Monday. I got a natural conversation. It's able to log into Workday, find out your actual thing, see what it is, and then it says, oh, you want that on July 15th? Sure, you've got 64 hours worth of remaining vacation. Is that okay? Like you would do if you called an HR hotline. Now, if you say, oh, shoot, what was my instance size on AWS for my cloud, right, my reserved instance? Context switch. It would go back and actually give you all those things to say, these are the instances. Can you add 64 gig of RAM to that one? Sure. You mean this instance? Yes. Like you're having that conversation. Oh, by the way, I forgot to finish my actual HR request. All of those things are happening because the system is able to interact with all of those individual systems and have a natural language conversation with someone. This literally is going to change the way that we interact with things. So if you look at our brain, it's everything from episodic memory. It can figure out what was happening before, right, to symbolic logic. What are you meaning by that? The intent, the natural language understanding. They speak in German and French and English, etc. It really has the ability to have that conversation with you. And process memory. It knows every process and can implement it and make sure that it's being applied the right way. So from a security standpoint, governance standpoint, phishing, all the other things that go on, it can actually protect what's happening. So the bottom line is this is like talking to a human, but fully omni-channel. So everything you see around her right here, you can take a text message, a phone call. You can come in through Skype. You can come in through Slack. All of those things are integrated back in as any channel to have a conversation with a human that needs to do something. Very interesting. And that is, here's an example of this one. Vodafone deployed this back out just for their IT service desk agents. And they're handling 40,000 chats a month, right, in 3 different languages. And their net promoter score or their effectiveness have gone through the roof. because 90% of those transactions can be done through an AI, digital labor, right? Digital colleague. And so those things are really, really changing the way it works. But the thing that blew my mind with this company is that they have a thing called digitalworkforce.ai. Okay? Now, imagine I can download a digital employee like I download an app from the App Store. I download a digital employee like an app from the App Store. How does that work? Well, the reason is that they've got 600 predefined experts in infrastructure that can go be stood up to do the job for you. So you can download an SAP expert. You can download a Workday expert. You can download a ServiceNow expert. And they've done this with 20 years worth of actual infrastructure automation expertise is built into this cognitive AI capability. So it's just one of those companies that I think everybody should take a look at because we never know exactly how it will be applied. What I'm hoping for is we're going to start to develop more of the actual L1 type non-physical interactions for data centers and other infrastructure layers that aren't touched yet. So I think these workers are going to continue to expand. So from that topic standpoint, digital labor will change what's happening. There's going to be the only way that we handle global scale, especially on a pandemic level. It's the only way that we would have a real-time type response to something, because right now hours of response or no response are just not a response. It's not acceptable. Okay, so that's topic number one. And just hold questions to the end. Feel free to write them down. Love to jump through any of this as we do that. All right, next one, micro edge. This is always fun. When I said everything's going to change, it's because of the start of one technology. 5G. Everybody's been hearing about this, and no, it does not cause coronavirus. Please don't burn down towers. There's been 70 towers burned down in the UK. Can you believe this? Because they think it distributes the coronavirus. It's just, anyways, there's some education we need to do. But 5G will change it. And the reason it's going to change it are these kind of numbers. Imagine the way that 4G and LTE worked, the difference between them. I'm going to have 100 times more bandwidth. Okay, it's going to be 10 times faster from a latency perspective. And I'm going to have 10 times the amount of concurrently connected devices at any given second. What does that mean? Everything's going to start to aggregate closer and closer to the user. All right, now 5G is starting to roll back out, and we're starting to see this performance, and there's going to be a lot more towers, a lot more Pico and Fempo cells all over the cities, because there's going to be more and more people. Well, one of the things that's going to start to concentrate this is this cool stuff. I don't know if you've seen this. This is at CET, or at the CSE show, Computer CES, yes, Computer Electronics Show in Las Vegas. This is one of the 8 prototypes that was built for Uber Elevate. Okay, so I live in Saratoga here in California, and I went to San Francisco every day. And it was a 2-hour door-to-door commute for me, right? Each way. This, I go down to the train station, jump on one of these, I'm up and over in 15 minutes. And this is going to be the same cost or less than an Uber ride. How much is your time worth? So when you start to think about that, it's already being implemented into real estate. So this is in Florida. So they're now allowing these transports to land these things back and forth. Okay, so there's going to be a whole bunch of this, how transportation is done and the need to be able to be closer and closer. Now, the next part is, imagine in the city when you start to concentrate more and more people, because that's what's going to happen. You're going to get the populations of cities double, tripling, or even quadrupling very rapidly because people can live on the outskirts and still get to work in less than a half hour and still afford to do it. That's going to change the skylines. That's going to change the makeup. It's going to change everything in cities over the next 5 to 10 years. So that also means that on the ground, there's going to need to be orchestration. So think of mesh vehicle networks, autonomous vehicles and how they communicate and how traffic flows work and applying all those AI patterns to do it. That stuff's going to start to drive the need for close edge proximity for it. And then even your interactions, even though we're not going to grocery stores or going to shopping malls and things right now, the augmented reality shopping experience is definitely going to change. You're going to walk in and guess what? She's standing there and they put a dress on her. It already knows her size. It's sized up based on what it saw from the cameras, and it can have it ready for her. So you can just walk around and see everything on you. That hat looks great on me. This pair of pants works. Everything is good. That's what the future is going to look like. But one of the most driving factors going on right now is gaming. Gaming will be the key for how much adoption there's going to be for 5G and demand of data. Okay, I don't know about you, but this is a gaming conference. There's 15,000 people sitting in that stadium right now watching 6 people on the stage play games against each other in a competition. Okay, this kind of a localized experience and the immersive experience of what that is going to change dramatically over the next 5 years. Why? Because 5G is opening the door to have extremely low latency, high performance experiences close to the user. And if you start to look at what the technology that's going to drive that, all of the new phones that are coming out are having AI chips built in them. The ability to now have fully immersive experiences and take full advantage of that bandwidth and that latency concurrently connected device. I always give this example about Pokemon Go. Pokemon Go had the need to suddenly find 40,000 servers in less than 2 days because of the demand globally that came up. You know, the cloud providers can actually do that scale, but now imagine everybody walking down the street, holding their phone up, pointing at a building, and they see every one of the rents for every one of those things. Or they have an experience, an immersive experience. You know, Mark, you've got all these sports things behind you. Imagine if you could walk around and say, oh, there's a sports thing going on right now, and it brings me to it, and I'm immersed in it. Like, there's just so many applications, and we don't even know what that looks like yet. The key is that the majority of these applications have not even been written. So the people that are going to be doing this are waiting for 5G to come back out because they're going to see the performance and the need, whether it's facial recognition or other AI aspects to make those experiences be very immersive. So when you start to look at what developers are going to do, they're going to be everywhere. They're going to be sitting in Starbucks doing their thing, developing the next application that you're going to utilize. Look at the App Store's performance, all those apps and what we use. Now imagine immersive experiences that happen. You walk into a Starbucks, it'll probably be a very different experience in the future than you have today. There's going to be technology all the way down to you and the way your devices are interconnected for that to happen. So the key in this is that the data that's generated, that data is the new oil. Edge is the refinery of that data, and real estate really is the last mile for it. Okay, so from a city standpoint, just think about it. Hotels, malls, apartment buildings, restaurants, offices, that's where people are. And you think about the last 1,000 feet, that's where the things are going to be. That's where the demand is. That's where the processing requirement's going to be. So you're experiencing a hotel, you're experiencing your office space, dynamic movement of people. Like, there's just so many aspects that are going to go into it. So remember back when I was saying we had 13 billion things and people today, going to 100+ billion of them. Okay, that's the stuff that I was just showing. It's going to be concentrated where real estate is. So when you start to think about the market, that's $4.1 trillion of economic opportunity right now in how 5G rolls out and how we actually deploy it. This goes into edge data centers. This goes into micro edge deployments. So another company to look at here that is doing a lot around this is called EdgeX. And what EdgeX is doing is building a platform that allows the actual performance of the last 1,000 feet. This is the way that applications work today. We have all the stuff going on in these cities of concentration. It's backhauled. We just talked about network earlier, back to some type of large data center that does a bunch of the processing. Now we have some front end and other aspects that are closer to the cities, but the majority of the load goes back to a core data center. Okay? Now, the issue here is what I just explained, that's not actually going to perform. You need the latency to be lower. You need the time it takes for that application request to be responded to do something to be faster. So you're going to need to get this closer and closer to it because the core isn't going to serve it. Now remember, this is not an or. This is going to be an and. Core data centers are going to continue to grow, but edge is going to now start to rapidly come up because of the need that's happening there. And if you think about the way that those connected devices are going over time, right? Another 80 billion devices are going to be added over the next 5 years. 80 billion devices? It's insane. So when you start to think of the future, we start to distribute these applications out to the edge. So what does that mean? Well, today we have basically core data centers, the majority of them. We got a bunch of devices at the edge. We're going to layer in these edge nodes, the deployments. And again, the makeup of those are going to be different. You've got, and I'm sure a lot of people who are working on this too, You've got micro edge, or you've got edge data center deployments that might be larger. It could be 100 racks, could be 20 racks, could be 5 racks, 2 racks sitting in a building, but there's going to be edge. Well, now there's even micro edge that goes even further down. And I'll give you an example of this. There's an underlying technology in this, and I've got one of these in my hand. You'll see on the bottom, this is a credit card server. Credit card server. This is a MacBook Pro in the size of a credit card. Think about that. It's an Intel i7 chip with 8 cores, 16 gig of RAM, has a terabyte of NVMe, and runs Kubernetes, all orchestration software on this little device. It is sealed in epoxy. It's used by the military today. What seals it allows it to have minus 40 C to 70 C of operating temp range with no cooling. All you need is just air blown over it. So this can sit outside. It can sit on the roofs. It can sit on the corners of streets. That's the kind of micro edge I'm talking about. That's going to now push closer and closer and closer, because suddenly I could orchestrate, 100 people on this thing. Well, then what happens if it's sitting in a Starbucks or in a movie theater or sitting in a stadium? All these micro edge deployments of how that's going to be, and then 5G allowing that data to be coming in 10 times faster with 100 times more bandwidth. That's the kind of processing thing that's going to be coming. And so this is what EdgeX is working on, is the ability to go back and deploy these. And there's many form factors of this, right? The micro edge, they've got mobile data centers, right? Things that are completely waterproof that can be out there too. But the point is, edge is going to explode. And where it's going to explode is you're going to have all these smart buildings. There's going to be a need for all the things in that building. There's going to be urban traffic management when it comes down to the orchestration I was talking about. Energy and resources, think of these power plants and that. There's just so many places that need this capability close to where the actual load is. So the punchline of all this is that there's new things coming out that are going to take full advantage to deliver experiences at the edge. And the edge demand will disrupt the way that we store, compute, and serve that data globally. And it's because of people like us. We're all going to be addicted and in those experiences. You're going to expect it. Can you imagine today if you didn't have a FaceTime call with somebody? Think about that 15 years ago. That was a pipe dream. The infrastructure wasn't there. Now imagine 10 times faster and 100 times more bandwidth. What else is going to come out? Those developers are going to just blow our minds. What we need to do is make sure we've got the infrastructure to support it at the last 1,000 feet. So edgex.io, edgx.io is something to take a look at and watch for, because they don't share everything on their site. It's just really cool. I can't share it right now, but there's just some really, really good stuff coming out from that. Okay, topic number 3, software-defined data center. So let's jump into this one. We've heard this concept for a decade. Everybody's talked about, well, we should use software defined. Software should control these. Okay, well, let's back up. 2009, how was it defined? It was really about optimizing compute, storage, and network resources, all that capacity, through hardware independent, meaning we're decoupling it, orchestration, and virtualization of software. So we're leveraging these technologies to now carve up these devices, compute, storage, and network, and allow those utilizations to go up. Pretty basic concept. Except it misses everyone on this call. This is compute, storage, and network. What about the rest of it? And if I look at it today, I believe that up to 50% of the power that's actually contracted and allocated to people is wasted. Now, is that because of bad data center management? No. That is data center providers that are at the mercy of customers' policies. And I was one of those customers. So for example, I would go contract 3 10 megawatt zones. Those 3 10 megawatt zones, we would now say we consume up to 6, maybe 6.5 megawatts of that 10 megawatt capacity. Why? We have to worry about disaster recovery, failover. We have efficiency losses and buffers from shared platforms, etc. All that adds up to where that 10 megawatts can't truly be used, because what happens if I have a failure? So there's a significant amount of capacity that's actually dedicated. And does that sound familiar? Dedicated hardware, dedicated storage, dedicated network. So if you think about this, the whole point of virtualization was to avoid the requirement to have dedicated capacity to things. So why are we doing this still in the data center? And if you look at that problem, could we do something about that? Well, look, lots of people have approached this, but again, hands are tied in a number of ways because, we've got derating. We've got breaker settings. We've got policy things to make sure that when things are doing maintenance or failovers, there's all this stuff in there to just make sure. So even that 2 megawatts above doesn't even take into account the redundancy on top of it when there's a failure. So the reality is it's a physical environment. There's limitations within that physical environment. And we have people that have to ensure that we can deliver on that SLA. Very critical. But what if you could leverage software-defined power, virtualization of power, to increase that utilization of it without compromising your SLA? Without compromising your SLA. That being one of the biggest pieces of this. So if you could do that, now I have the ability to say, well, then that 4 megawatts is available. Because in the example I gave, three zones, 10 megawatt contracts, 6 megawatt used. In essence, I'm full, and I would have to build out another one. Now, that means that if I'm with a co-location provider, like many of you in Arizona, you'd have to put out another $100 million to build another 10 megawatts at an average of 10 million, right? To just give me another 6, when really I could just distribute that across 2 megawatts in all 3 of those. There's a $40 million cost avoidance just by utilizing what you have today. So that's the opportunity. So I look at this as, all right, well, we need to actually have a new definition for the software-defined data center. And that definition is very simple. We need to optimize the compute, storage, network, and facilities, resources, through a hardware-independent software orchestration. There's a lot of words in this one. The whole point is we need to treat power like we treat compute, storage, and network. They're dedicated resources, and we can virtualize them. That allows us now to have the 4th pillar of a software-defined data center completed. That's where everything starts to really optimize. And look, at VPS, and I stepped into this interim role in February, and just a little background. You remember I had done 30 years in the industry, and I was stepping away into advisory roles, and I wasn't planning to do an operational role. I joined the board of VPS, and then the investors and others asked if I would step in and help. And I really think that this is the transformational part of our industry right now. It's the thing we have not been able to get our arms around. But the reason we haven't is that everybody can come into this and say, I want to improve the economics. Great. But I don't care if I'm saving money if my damn data center goes down. My job depends on it. So what are you going to do about that? So the main thing is that you have to have these first 2 in tandem. You can improve the economics because you're going to increase that, but you must maintain or increase the resiliency. And one of the things that I always look at is when you think about the human reaction time, right? Seconds, minutes, hours, and you think about software reaction time, milliseconds. And you have policy and consistency. If you allow software to be able to take policies and implement them, they're going to be consistent. Many of us have had, outages in our history. And it usually is 99% of the time a human not following a process or doubting the system and trying to take over something. So when you now trust the system that you've put in place, that you've actually tested, that you do drills and maintenance on all the time, it works. And you've built redundancy into that one. Now, if you're able to say, I can take software to orchestrate across that, you can achieve the same things. And I'm going to give you a practical example of what that looks like. So ICE for us is intelligent control of energy. Intelligent control of energy. This is the software orchestration. And what it allows you to do, take the chart on the left. This is basically a power pattern, consumption pattern, at an 80% rated breaker. Okay? So I am under that breaker because of those patterns. And a lot of times I'm even further under that breaker because of my policies to make sure I never get to that close to that point. If you're able to now add capacity and allow you to burst from a power perspective within that, you can still maintain. But how does that happen? So there's a hardware-enabled software solution in this. So what we've built is a thing called an ICE stack. And this is the only thing, and this is what I was really, really happy about when I joined up with VPS, is there's a hardware product that I didn't realize was the only thing in the industry. Like nobody else has this product, and this is enabling us to get to the software. This is on-demand parallel energy injection. I'm injecting current north of the rack, south of the UPS, at the RPP or PDU. I can inject current to protect my load. Injecting current in real time. So this unit on the left here is an ice block. That's basically, think about it, a three-phase. I've got batteries inside of it, and they're able to inject energy for a period of time. This is not a UPS. This is augmenting the capability of the UPS. I'm injecting energy to provide my safety net that when things are unpredictable or my phases are out of balance or something else is wrong, that I've got protection at the actual distribution layer. Because the customer's behaving badly downstream, whether they're doing phase imbalance or they're doing workloads that are increasing that are unexpected, it still is the protection upstream that the data center provider has got to be able to do. So adding a safety net there to say, I can let those customers continue doing what they're doing. I have a safety aspect here that allows me overall to increase my capacity. I can consume more because the buffers I put in are covered by this power bursting. And then I can use software to orchestrate between them. That allows me to unlock, remember that 10 megawatts. I can unlock that stranded capacity because I'm not just putting software on top of something. I'm orchestrating devices specifically to solve challenges that all of us have faced every day. We've all got phase imbalance somewhere. We all have circuits that are at risk of tripping, or we have circuits that are highly underutilized. So this is a practical way to go back and look at, can I implement something that gives me confidence first? Can I get to that point where I believe this is going to apply policy and inject and do that curve on the right 100% of the time? And then from there, then I can now start doing larger software orchestration. So that's why it's a hardware-enabled software solution. And here's the other part to think about. Software-defined data center is not new. And everyone looks at this as a concept that people should be, it's the future. It's something that will happen in the future. The reality is this is full production at scale already. All the hyperscalers, not kidding, have already implemented at different levels of maturity software-defined data center architectures that are able to do this, but it's their secret sauce. They do it in their own facilities and they get extremely high utilization out of it. I've seen it directly, but they can't get this from their partners. Why? Because they're bound by an SLA, both sides. So imagine if you could open the door up to be able to say, I can optimize this one, because there's 4 streams across this. One, I can do power bursting to allow me to have a safety net. The next one is I can do dynamic power to allocate power where I need it. Third one is power capacity manager, where I could do oversubscription management. The fourth one is spot power. I could take my redundant power and sell it as a contract with 2 nines. Why not? That's a whole nother revenue stream. Right? Mark, you could sell that all day. So I look at the potential in this, the amount of stranded capacity, but we have a conservative industry on purpose. Our industry has to keep the lights on. The infrastructure needs to stay up. That's why you can have this incredible cost optimization, but you must maintain the SLAs. That's why software needs to get into it. And guess what? The hyperscalers have been doing this already. Now remember, the other thing to look at, I mentioned about the data growth early on. That wave is coming. The other part is, for everybody who's serving hyperscalers, you've already received the price pressure. You've already seen the margins shrinking, but they are one of the largest consumers of infrastructure, and they're needed, right, to deploy back out. If you can now figure out a way to optimize your infrastructure, unlock that stranded capacity, you're going to increase your margin. You're going to lower your cost for your customers at the same time. How can you get both of those? You've got to embrace a software mentality that allows you to control it and achieve those 2 different things. I can lower my cost and I can maintain or increase my actual SLA, the resiliency wise. So that's why it was exciting to me. This is kind of that last block we really need to get into. And what I want to do is think about the every click improves the future. If we're going to have that much growth, digital infrastructure right underneath, we have to bring data centers up to that next level. We've picked the low-hanging fruit. Everybody on this call has actually done this work. They do it every day. But think about how much stranded capacity you have. What is it in that infrastructure that's holding you back from actually unlocking it? And I'll bet you it's a number of the things I just said. Why? Because in the portfolios I had, same reasons, same stuff, same policies. Can't take a risk. Can't do this one with that because I'm going to have failovers, etc. So that's why I believe, wow, there's a great opportunity to have a real hardware solution that gets the hearts and minds of the engineers, that it's proven. Then it can now be taken further and further, and we can take a logical approach. Because look, it took 10 years for virtualization to become the standard. Nobody goes dedicated servers out there for the majority of this, except for machine learning right now. Everybody else is doing shared infrastructure. So that's why I believe 2020 is really the year for software-defined data center. And that's why I stepped in to help the company actually get this focus on what we're doing. So I'm having a blast, by the way. Back to a startup company and doing a small thing like this, it's just phenomenal. I've been at large companies for a while, but man, you can just move, right? People are there, bang, we can go get that thing, turn it around like yesterday. It's very, very cool. Okay, so the 3 topics we talked about: digital labor, micro edge, and software-defined data center. That's the summary from here, and some companies to take a look at. But we can open this back up for questions. Mark, is that cool?
Very cool. Thank you. As always, you blew everybody away. You always do. Very exciting stuff. I'd like to open it up if there's a list of questions. Michelle, do you have any questions that have come in from people out there?
Yeah, first question, Dean. Can you speak a little bit more about the technology in the ice block?
Yeah. Let me go back here for a second. So to the technology, if you got a specific question, let me know. But this is a just think of it, a 3-phase injection. You put this to take a circuit at a breaker, a circuit out of an RPP or a PDU, and you can stack these up. But the reality I've found is that 3 of these in an N+1 configuration is probably the ideal. And remember, you've got lithium batteries inside of there, and they're injecting energy for a period of time. And then we're using the software to calculate the life of that battery like you'd have with other battery technologies, but also when you inject. So you can set your policies to move them down. But remember, it's a 3-phase injection. So I'm equally injecting all that power back in. So it's current. I can stack them up, but I think it's overkill to have 180 kVA in a 225 amp or a 400 amp RPP because it's protecting the upstream breaker. You're injecting energy for all the circuits that are consuming, but in the end of it, it's about how do I make sure that RPP or PDU breaker is not going to exceed. And if it does, I'm discharging during those periods. So it's covering the unexpected. And the 1845 watt hours of runtime is based on the minimum that you'd have based on load. If there's maximum load, this is the kind of runtime you get. So there's also an ice pack that allows you to add more runtime. But a standard configuration for us is a 3 ice block, N+1, 36 kVA, 1800 watt hour plus worth of runtime. And yes, they're UL certified, qualified. So we got that in February as another little bonus. It's been a year plus worth of work. So that's ready. We're doing UL labeling for the stack itself. But we've got demos set up if you'd like to take a look at that one, because it's neat to see the reality of it. The workload starts coming up. You see what happens when it discharges, like the stuff on the upper right corner there. And it really is the policy that you set. You can do manually. You can do a policy, put it and forget it. That's a good start. But in the end of it, you now start orchestrating the top level. You see what consumption is happening across the whole suite. Imagine 10 PDUs. I got 2 PDUs with an issue, and I land this ice stack right in those 2, because I don't need it across everything. You're augmenting the UPS with additional capacity for spot problems. Then from there, you can now monitor what's happening across the board. Then you can start say, I actually want to do dynamic policy management, and it'll push the policies to the actual hardware itself to be enacted. And then if you lose network, those policies still keep going. So hence the SLA aspect of it. Something goes wrong, network goes out, some other piece of it, these things are just going to keep firing away and doing what they need to do. So hopefully that answers part of the question. Yeah.
On that same topic, you mentioned that all the hyperscalers are doing this already. The question is as they enter into the colos, and several colos out there have done some hyperscale deals. Do the hyperscalers provide you some leniency on the SLAs with that? And I'll throw that out to Anthony to answer. Or are they still holding you to that high level SLA?
So I think Anthony's frozen. There he goes. Okay. He's back. So Anthony, go ahead and answer, and I've got an answer as well. But
You jump in, Dean, and I'll go ahead.
gotcha. So okay, this is what I've seen, and I've talked to all of them.
Yeah.
Right. Because I really wanted to understand, what is the target market for VPS, and it really is that we need to provide a competitive advantage for the co-location companies. Because right now, hyperscalers are building, and they're getting down to, design, build, and blocks, et cetera, and the margins are getting lower. If there's a way to go back and offer capacity, especially globally, hyperscalers and others are going to consume it. So the limitation right now is there's still an RFP. The RFP has a checklist. The checklist is coming in. You're going to guarantee an SLA like this one. So it limits the ability for this technology to go out. But, for the contracts for something like that happen. You got a tier 3 with a 5.9 SLA, that's what I expect. That's what it's going to be, checkbox. I don't care about the utilization, it's on you. Now, if you were able to offer up and say, by the way, there's another 3 megawatts in this building that you could have with a 2.9 SLA, is it interesting to you? Now you offer an API to them that they can dynamically manage infrastructure at the co-location partner company. That could be interesting. But that's a different approach than a standard RFP. You have a conversation about a dynamic SLA. And look, every colo has the ability to do this because you can decide how you're going to deploy capacity out. It still comes down to how do you manage it? It goes back to that original thing. I'm going to give an SLA, but last thing I want to do is actually have to enforce that SLA. Like the 2.9s. So hence having this safety net on top of it, because you don't know exactly what's going to happen. If they come in and they consume that redundant power that way, they're going to be having high utilizations because they do that in their own facilities already. They're getting the 80, 90+% utilization. So then how do you hold up during those little periods? Protect yourself from those things. And that's where I think the co-location providers have an opportunity to look at a different business model and how they approach adding value to the different levels of customers. Because remember, a hyperscaler is going to come in, expect a really low margin, lots of capacity, and the same uptime. Then you've got wholesalers, and then you've got retailers that now your oversubscription management is just orchestration. So there's just a lot you can do with software to now optimize your business, is what I'm seeing in these conversations.
Great, thank you.
Sorry, Anthony, that was
Anthony, was
okay,
that?
there you go.
Well,
So
we all know customers would love to pay on their utilization and not on what they've contracted for. That is the goal of most of my customers today. How do we do that? Well, I think that's a path to be able to begin to see it that way.
And I looked at just in my past lives, I get these reports, and I would ask the same thing. We're contracted this, but why only this utilization?
Mm-hmm.
And then you go back and say, that's actually us. Crap. Okay, it's the policy we put here, or we have projects that are not quite there. We haven't done all the containerization. So, and then we haven't done all the failover testing. It's like, okay, then we're holding the partner at our mercy, and then it's their capital sunk in. It's their money, right? So how do you get more yield on that capital? I think is why I believe there's a great opportunity in this. A safe way to go into it to increase the yield on that capital, right? That return.
Great.
So Sean
I have another
raises-
question. Oh yeah, we've got one question from Sean, and there's one question in the chat box. If you could talk more about the temperature range on the micro edge phone size device.
Yeah. Temperature range. So let me see here. Let me just do it this way. I don't know if you can see it on that. So this again is a biodigital PC, they call it. So because of the epoxy, the minus 40C to 70C operating range. Okay, minus 40C to 70C. It's because it is a heat sink. But the reason that they do this epoxy on it is that for security. So it's 100% made in the US. That's why the military uses these today. If you try to remove the epoxy, you destroy the card, right? It's waterproof, dustproof, shockproof, like all those different things. So suddenly it's ruggedized and I can put this back out there, right? And have these kind of really, really drastic environments. So imagine Arizona. What happens if you're putting it on the street corner and it's 128 Fahrenheit?
Yeah.
And there's a haboob and all of a sudden there's humidity.
Right.
Doesn't matter. Good. You know, where we got to baby a lot of the stuff in the data center and do a lot of extra things. That's where these kind of things rolling out changes the way you can compute and doesn't have as many limitations. So I'm not sure if that answers the question, but that's the thermal range. And I'm on the board of this company. I found this one. I'm like, this is cool. This is the
We've
future.
been talking about smart cities for quite a long time, and you know the easiest way to do a smart city is ground up. You know, to go, but your population is in the older cities, and is that a technology that might make it easier to be able to deploy to create a smart city? That technology that you're holding in your hand?
Oh yeah. So cities are. I mean, the whole point is to optimize what happens in the city. You know, the experience in there, and like I talked about Uber Elevate and getting more people into the cities, it's going to happen because I think it's Dallas, Sydney, and Paris, I think, are the ones with Uber Elevate. So they're figuring out the patterns. They've already got the, FAA and everybody in this. So there's going to be the ability to get back and forth to work into the city. So that's going to increase the volume of people. So what's built is built. Now, city planners are looking at data from Uber specifically on planning themselves. Where do people move? And imagine Uber had the movement of every car, they really understand it down to the minute. So they were sharing that data for them to decide, what do we build? Where do we build? Where's the congestion? That kind of thing. So insights. Now, when you start to think about what happens in these cities, with this new influx of people, and then this new bandwidth opening up all those things, and that need to have the compute, this is one solution. There's other things out there, right? But the point is, it's going to get closer and closer. So even if you put out a modular data center, remember the container stuff we've done before, but just a block type thing that's out in the city, Vapor.io is doing these at the towers, right? You've got a number of these people that are doing it at different places, on the roofs, etc. Now it's taking it one step further and saying every apartment building, every apartment, every hotel room, everything, that's where you start to get a whole different way of thinking. Because before it was, I have to worry about 50 to 200 millisecond latency. Well, now I've got almost zero latency. What do I do with that? Wow. That means that I could have an experience in a hotel room where it's just built in. You sit down and watch a movie and you got a fully immersive experience. Or you're having, I don't know, there's just so many applications of it. And we don't even know what they're going to do with it. This is where the creative minds, like they do on the App Store, they're going to start coming up with these because the floodgates just opened. They have the ability to do as fast as possible with whatever bandwidth they want. And again, gaming is going to be the experience that really triggers it first. So smart cities, absolutely.
People spending time gaming all, the last 3 months.
Yeah.
I know my kids.
For sure. Yes. I'm sure it was you too, Mark. Come on now. Your hair is getting longer. You know it is. Yeah.
Yeah.
I need a haircut too.
Okay, we're going to jump to Sean. You've got a question here. I'm going to unmute you.
Hey, Dean, how's it going?
Good.
Hey, so quick question. When you look at, power optimization, one thing that we've also run into is, and I think everyone that operates, we don't dictate what sits on the equipment.
Yeah.
And, when we talk about hyperscalers, those are guys that have optimized their software.
Mm-hmm.
They know how many containers they can put on a VM, and they know how to push the limits there. But I think when you talk about most companies, they're not there yet.
Yep.
And so to me, when I look at power and optimizing it, the first step is making sure that they know how to use the hardware to its fullest potential.
Mm-hmm.
And then take something like the ice block after that to make sure you can optimize the rest of what's left, to fill in the gaps where you're not able to optimize. I mean, what are your thoughts on that? I'm just curious.
Yeah, actually, let me ask you a question. So, in what you're explaining right now, like, are you in a co-location or are you an enterprise data center, hyperscaler?
Sean Tugwell, I think.
What's that?
Sean Tugwell. So
Is that
He knows.
Tugwell?
yeah.
Yeah.
You didn't have a last name in there. I know Tugwell. Okay, so yes, Sean, we know this very well. We know that there's limitations. Now, here's the thing: if you could now remove yourself from those decisions, in other words, the ideal solution is what the hyperscalers have been doing. They have a fully integrated stack that allows them to optimize the hardware, right? They're now able to sense and see the power and optimize the power for it so they can adjust things dynamically. That's really the truly shared environment. Now, in a co-location environment, you're fully at the mercy now of this. Well, what if the co-location could say, I'm still guaranteeing my SLA, but now based on what I have, I've seen where things are hot, I'm injecting energy there. The other parts of it, now I can say, I'm doing a calculated risk because software is watching what's going on in usage. Because you and I both know that when it gets up to the UPS level, all those things flatten. It's a pretty consistent draw. It's not these wild swings. It's at the rack level where you've got, right at the server level, you got more swings. So when you start to now roll it up and it keeps flattening out as it goes up, if I can now aggregate at the PDU level, you can allow them to continue to increase, and you can now oversubscribe with safety. So even though the optimal thing is to try and get the compute environment that way, we know how hard that is. We also know that the misalignment for different companies at different maturity levels, it's just going to take time. So hence, how do the partners provide an environment where they can get the maximum return on their capital investment without risking the SLA? So take the companies you've worked at, same things. Expect an SLA, you're going to perform to here. So if the co-location companies say, I can actually do that, and I can increase my actual capacity sold by another 20%. My capital yield, all day. And how much is that? I throw in a small amount of software and an augmentation of hardware for it, and I unlock 5 megawatts. Hey. All right, Anthony, how many times would you sell that? You might have some high margin in that. I'm just saying. Sean, does that answer your question, or are you going to call BS on me?
No, no, it's a good answer. I think, the industry needs something like, Mark made his comment about usage based, and I know I'm one of the people that beats him up about usage based all the time, because, and I think all you colo providers out there, you should be looking at ways to reroute or redistribute power so that we can do usage based, because that's the only way you're going to be competitive with cloud in the end, long run.
Yep.
Well, with Google and and all those people.
Yep.
You still have your tractor, Sean?
I do, although Rich is trying to make me give it up and move to Phoenix, so I might not have it for much longer. We'll see.
Okay, Colorado's good. Great to hear you again. It's been a long time.
It has been.
Other questions?
Yeah, there's another question here. With the permanent shift of everyone working from home, do you expect that communication providers will start integrating edge capacity in their home as part of a communication package? And do you think gaming is driving that?
So again, my opinion, I think that if you look at the latest bandwidth that's actually been pushed out now, I'm getting 20 megabits at my house. People are getting a gigabit at their house, so that's been happening for the last 5-10 years. They've really been rolling out the capacity. Now, some of the things that I see, like take AT&T and Comcast or anybody else who's got some kind of streaming service and those types of things, they've got a console in your house. They want to remove the console. They would really like to be able to say, it's just, you've got a very simple thing. Imagine one of these that's just been able to interact back and forth, but then they start to aggregate by city block, by, something where they have the ability to distribute out. Okay, so first off, there has to be the lanes to get there, the bandwidth to get there, and the speed. The second is that they have to figure out the optimal way to do it. And right now, having all these set-top boxes is an opportunity, but I think it's going to change. And so when you look at how do they distribute out in all these smart cities, They're going to start to say every corner is valuable real estate. Every floor in every hotel is valuable real estate, right? And how do I aggregate homes on a residential area? Well, we've got telephone boxes at the end of the rows of those streets. And, that's still basically almost zero latency when you're talking about processing from a block away. So I see a lot of that stuff starting to push out. So smart cities, it's going to be smart infrastructure deployed closer where people are. And so residential is going to get this as well. So that's all going to change. And again, you've got 5G. You also have Wi-Fi 6. It's going to be able to penetrate walls better than 5G. 5G is going to have these femtocells and picocells. So there's going to be a mix of these two technologies that's going to allow this performance to get closer and closer. So it's not going to be either or, it's going to be both, just like we have with LTE and Wi-Fi today, right? That stuff's going to be there, but it's just, the whole point is it's going to increase the ability for demand to go up. So other questions?
Any other questions?
I think that's it. We're right at 1 o'clock.
Great. Well,
thanks for listening.
thank you so much, Dean. It's a pleasure to have you on. Thank you, everyone that were able to participate and join. Thanks for the questions. Our next event, we're still looking to have our casino night coming up in the fall, and it all depends on how we are doing here with leveling out this curve. So everybody, thank you for your time. It was awesome. Anthony Bollner, thank you for your participation. Thank everybody for your participation, and be safe.
Hey, could I ask one favor?
You sure can.
Could everybody try to turn on their video? I'd love to do a screenshot.
Isn't that awesome?
Yeah?
Absolutely. Great idea.
See these faces. Alex still wins, by the way.
Hey, Dean, I'll sneak in one last question.
Yeah.
Where do you see in the workforce development, the educational side of things, that universities and community colleges and maybe even at the K through 12 level are going to need to step up and kind of change how we're doing things to facilitate this mammoth growth in the digital infrastructure area?
What a great question. Thank you. I meant to say something about this. So Infrastructure Masons has got a scholarship fund, right? We're trying to go back and drive the pipeline to get more talent in, and really trying to get to increase the diversity. So how do we get these different sources of talent? So right now the problem is that the universities and the colleges and the vocational schools don't necessarily have curriculum that's matched the stuff that we need. So we have 23 programs that are actually across 13 different education entities, right, that we're giving out scholarships for. We need more of them. And then the other one is maybe there's postgraduate certifications that can be simpler. Now think of like CNET training or other things that allow you to get people in, and then they are trained on the job. But we need that pipeline. Our problem right now is awareness. The people don't know what this industry is, and they don't understand this great career that we all have and the opportunities with it. And then they don't know what programs to go into. So that mismatch is causing this pipeline to be dried up. And you're absolutely right. The amount of demand that's going to come in here is scary. How do we feed it? Because by the way, right, not to pick on Tom over there, but we're all graying out. Okay? So think about, yeah, I know, Tom. the 30 plus %.
My ass off at that compliment for how I've grayed. Thank you.
You're welcome. You're welcome. Nice to see you again, Mr. Maples. So, but the graying out, there's like 30%, I think, of the workforce that's going to be retiring in the next 5 to 10 years. That's a big issue. And then you think about that demand. So I would say that if you have, we're always looking for help in this, right? We've raised over $300,000 in scholarships. Our problem is we don't have enough people applying for them. And by the way, Anthony, wherever you are, thank you, Stream, because they sponsored 3 of our different Food for Thoughts dinners, right? And we raised money for the scholarship every time we did it, right? It's just, we need that one, but we've got to be able to have awareness, alignment with education programs, and then we need a pipeline to get those people in. So I think there's more and more work we need to do as a community here to make that happen. So stay tuned. We'll be sharing some more stuff. Awesome. All right. Well, everybody's got a smile for me. I want to get this picture. All right. 1, 2, 3. Nice. Hey, Alex, you're not smiling. All right.
Tom, look up.
3 windows. Wonderful.
Thanks, everyone. Thanks, Dean.
Great hanging out with everybody.
Thank you, everybody.
Thanks, Dean.
Thanks for listening.
Sure. Thank you.
Okay.
Thanks for lunch.
You're welcome.